operations. Alright, before we get into this, let's review what we just went over out of 2-3. If I gave you that f of x was equal to x squared plus 3, and I told you to find f of 2, what would you do?
Put f of 2
Put 2 over CX.
Put 2 where you see it in. So that would be 2 squared plus 3, or 4 plus 3, which is 7. So f of 2 is 7, right? Well then, let's say if I ask you to find f of a, what do you do there?
Wherever a is.
Put an a in place of the x, right? So that would just be a squared plus 3. Leave me there. Now let's say if I want to find f of x plus 1. What do you think I'm going to do on this one?
X plus 1.
X plus 1 in place of the x, right? So that would be x plus 1 squared plus 3. Well, how do I find x plus 1 squared? Do form method. That's x plus 1 times x plus 1. Of course, we got to add the 3. So we do our form method. X times x is x squared. Outside is x. Plus the inside, which is x. Plus 1 times 1 is 1. Plus my 3. So I get x squared plus 2x plus 4. Right? So this is kind of from 2.3. This is what you did for homework for today, or what you were supposed to have done for today. Is everybody okay here? We're going to add to this stuff. All right, well, first of all, we're going to talk about function operations. Okay? And this is going to be when you're adding, subtracting, multiplying, dividing. Then we're going to talk about composite functions. If you remember from maybe intermediate algebra, this is where you did like some students call it fog. It's that F, little open 0, G, F composed of G. We're going to go into that stuff, because that stuff's going to kind of look a lot like what we just did right here. But first of all, on function operations, if you were given F plus G of X, well, what do you think that means? Most of these are going to be common sense. What do you think this means here? F plus G of X. It means you're going to add the two functions together. F of X plus G of X, right? And if you have F minus G of X, well, that means you're going to subtract these two functions. Or if you had F times G of X, that means you'll multiply them. Or if you had F divided by G of X, this means you'll divide them. Of course, on this one, you've got to remember that G of X cannot be equal to 0, because we can never divide by 0. So these are my operations on functions. Now we're going to do some examples. We're going to use them. Alright, so for number 1, let's say for these problems, I'm going to tell you that f of x is equal to 2x squared plus 3, and g of x is equal to 3x minus 4. Okay, on the first one, let's say if I want to find f plus g of x. Well, by definition, that means that I add them. I want to say f of x plus g of x. So that means I'm going to say 2x squared plus 3 plus 3x minus 4. So we're back to just adding polynomials. Remember combining like terms? Right? Is there anything in front of these parentheses that I need to distribute? No, so you just remove them. And then you combine like terms, just like we did with adding and subtracting polynomials. My highest exponent is the x squared. There's not another one, so you bring it down. And then I have my 3x. Now I can say 3 minus 4 is negative 1. So that would be your answer for that problem. You just add the polynomials that you're given. Also, we can have numbers that go in here. let's say for number 2, if you're told to find f plus g of 2. So instead of having f plus g of x, we just add them together. We have f plus g of 2. So that means I need to say f of 2 plus g of 2. And there are 2 ways to do this problem. I'm going to explain to you in words the hardest way, and we're going to do it the easiest way. First of all, if you were going to do this, you could do what we did here, find f plus g of x, and then once you know the answer here, you can plug the 2 in, place of your x's. And that's okay if you've already had to find this, but most of the time you're not going to find this part first. So if I were you, I'd come down here and I'd just say find f of 2, just like you did for your homework for today. Go to your f of x function, put a 2 everywhere there's an x. So I would say that's 2 times 2 squared, which is 4 plus 3, or 4 times 2 is 8 plus 3, which is 11. So f of 2 is 11. Now let's find g of 2. Well, that would be 3 times 2 minus 4, or 6 minus 4, which is 2. But now what's this definition tell me to do with my answers?
Add.
To add. So my problem here is equal to 11 plus 2, which is 13. So your answer would be 13. Now I want to tell you something real important that I don't want you to get confused. If there's a variable in this, in your original problem, your answer is still going to have variables in it. If what's inside this parentheses is a number, your answer is going to be a number. Okay? Now, like I said, you could have got the same answer if you'd have put a 2 in here. Like I said, this is f plus g of x. And since my f of x and g of x are the same, I could have put the 2 here. You'd have 2 times 2 squared plus 3 times 2 minus 1, or 2 times 4 is 8, plus 6 minus 1. Or that would be 8 plus 8 plus 5, which is 13. Right? So you'll get the same answer either way. I personally think you'll make less mistakes if you do it this way. Alright, let's look at some more here. Using the same f of x and g of x. Number 3, let's say if I want to find f minus g of negative 3. So by definition, this will be f of negative 3 minus g of negative 3. And if you don't need to write that step, then you don't have to. Alright, so I'm going to give you a second to find f of negative 3 and g of negative 3. Here. Did y'all go ahead and subtract them?
Negative.
I did.
Alright, let me look, because let's see what I get. So that's 2 21, right? G, do what? G of negative 3 would be 3 times negative 3 minus 4, or negative 9 minus 4, which is negative 13.
Okay, see, I didn't, that's,
Remember, when the signs are the same, you really add and take the sign of the number. You only subtract when the signs are different.
So it's 34.
So yes, your answer would be 21 minus a negative 13, and then what do two negatives make? Positive, so it's 21 plus 13, which is 34. Okay? Good on that one? Alright, let's do some more with this one. Number 4. Let's say for number 4, if I wanted you to find f times g of 1. F times g of 1. So I need to find f of 1, and I need to find g of 1. And then I'll multiply those two answers together. So find f of 1 and g of 1. Number 5 we'll do divided by g. Doing okay? F of 1 would be 2 times 1 squared plus 3, or 2 times 1 is 2 plus 3, which is 5. G of 1 would be 3 times 1 minus 4, or that's 3 minus 4, which is negative 1. So if I'm multiplying them, I need to say 5 times negative 1, which gives me an answer of negative 5. Good there. Number 5, I'm asked to find f divided by g of 0. So I need to find f of 0 divided by g of 0. Well, let's see. F of 0 would be 2 times 0 squared plus 3. G of 0 is 3 times 0 minus 4. Well, anything times 0 is 0. So here, did you get just negative 3/4?
I have to get to that one.
Okay. But you can handle that. Alright?
How you get negative on the top?
Well, if the negative's on the bottom,
Oh.
you can always put it on the top, put it out front,
Oh, okay.
either way. Alright, let me give you two more functions. Let's say if I tell you this time f of x is x plus 3, and we'll let our g of x be 2x minus 4. Alright, so for number 6, let's say if I want to find g minus f of x. Doesn't always have to be f minus g. You can subtract the functions, whatever order it gives you in the parentheses, that's the order you subtract it. So if you want to find g minus f of x, you need to say your g of x function minus your f of x function, right? Well, g of x is what here? 2x minus 4 minus f of x, which is x plus 3. And this is why it's going to be important that you keep these in the parentheses when you subtract these functions. Because when you're subtracting, what do you have to do with the negative? You got to distribute it, right? Which changes all your signs. So this is actually 2x minus 4 minus x minus 3. So now when you combine like terms, 2x minus x is x. Negative 4 minus 3 gives me negative 7. So your answer there would be x minus 7. Let me see how good you can do on this one. Let's say if I want to do f times g of x. So we need to say f of x times g of x. What do you think I'm going to do here? Go multiply them, which means you're going to have to do what when you say x plus 3 times 2x minus 4?
Distribute.
You're going to do form method, right? A binomial times a binomial. So that means on this one, multiplying the first terms together, I get 2x squared, outside minus 4x, inside plus 6x, last minus 12. So that's 2x squared plus 2x minus 12. Okay, there. Alright, let me give you one more with these. And we'll, that's why anytime you do them, if it's got an X in it, keep what you've got in parentheses until you've taken care of the operation. Number 8. Let's say if I want to find f plus g of 3. See if you can do this one, start to finish. So that means I need to say f of 3 plus g of 3, right? So f of 3 would be 3 plus 3, which is 6. G of 3 would be 2 times 3 minus 4, which is what, 6 minus 4 or 2? So my answer will be 6 plus 2, which is 8. Everybody okay on that? Last one, number 9. Let's say if I have f divided by g of x. This is probably the easiest one. So that's f of x over g of x. So that would be x plus 3 over 2x minus 4. Okay then.
Oh.
Alright, everybody okay on function operations? I think the mistakes you're making are just careless mistakes with your integers, adding and subtracting. If you're worried you're going to make a careless error there, use your calculator. Alright? Next, we're going to talk about what's called the difference quotient. The difference quotient, you're told, and I'm going to use the notation M, that the difference quotient is also the same thing as finding the slope of a line. Or if you go on to take higher level courses, a calculus course, it'll be the slope of a curve or anything at a particular point. You can use the difference quotient. So the difference quotient is the same thing as the slope. But you're given f of x plus h minus f of x all over h is your difference quotient. Okay? It's not going to be near as bad as it looks because I'm going to show you a long way to do this, and then you're going to get real smart. But this is the formula for the difference quotient. It will be given to you on your test. You will not have to memorize it. All the formulas will be on the test. Alright, so let's say if you were given that f of x is equal to 5x minus 2. And we want to evaluate the difference quotient. Well, the first thing we need to do is find, the only thing here we don't know, h is going to be just a constant number for right now. We're just going to treat it like a variable. But we need to find f of x plus h. We were given f of x, so we know this, but we need to find f of x plus h. Well, whatever's in this parentheses means I put that in place of the x in my problem, right? So to find f of x plus h, that'll be 5 times x plus h minus 2. Do a distributive property, that means this is 5x plus 5h minus 2. Now out of this whole formula there, that's the only thing I don't know. Everybody okay here? Finding f of x plus h. Now let's plug into this formula. If you're wanting to find f of x plus h minus f of x all divided by h. Well, f of x plus h I just found is 5x plus 5h minus 2. Substituting what we found that to be in place of it in the formula. Minus f of x, that's minus my original problem, 5x minus 2, all over h. So this is the f of x plus h that we just found, minus f of x. F of x is my original problem, all divided by h. So far, so good. Now we just got to clean it up. Let's distribute that negative and combine like terms. So that's 5x plus 5h minus 2 minus 5x plus 2 all over h. Well, what happens to these 5 x's?
They could cancel
They
out.
subtract out. What happens to negative 2 plus 2?
Cancel out.
They subtract out. So all I'm left with is 5h over h, right? And what happens to those h's?
They cancel out.
They divide out, so my answer is just 5. Okay. We're going to hopefully get into today talking about linear functions, the lines. Do you agree that this is a line? Do you remember from a previous course that f of x is equal to mx plus b, or you might have had it as y equals mx plus b? That slope-intercept form of a line. If your line's in this form, what's the slope?
L.
The number in front of x, right? What's the slope of this line? 5. What was my answer to this problem? 5. The difference quotient is always just the slope. So when it gets on my test, I'm not going to make you show me all this work. If you can look at that and say, oh, I know that's a line, and the slope of that line is 5, and you just put equal 5, you're going to be okay. Okay? On the exam, there's one like this on the final exam every semester. But you can look at it and say, oh, I know that's a line, and I know the slope of that line is the number in front of x. When it says slope-intercept form, then you're going to have your answer. Okay? All right, so I'm not going to spend a lot more time there. Now we're going to go on.
What if it's like 3/4 x? Is that answer just be
3/4. Yeah, 3/4. That's whatever your slope is. The only time it wouldn't be, which we're not going to, you'll get more into in calculus, if you had like a quadratic function, like 3x squared plus 2x plus 5. That's not the, you'd have to do the whole definition to get it for that one. But that's not what you're going to have in this course. That'll come later. All right, next let's talk about composition functions. Composition function looks like this. Like I said, some people call it fog, but that little O is always the open up. circle, and it's called f composed of x. That means that's f evaluated at g of x. That means you put your g function inside of your f function. You'll put one function in place of all the x's in the other one. Basically, I want you to think of it as walking backwards. You get your g of x function, or if it had a number there, you get the answer, and then you plug it back into the f function. You walk backwards. You take the g of x, and you put it inside of the f. Or if you had g composed of f of x, this means you put the f of x function inside of the g function. So everywhere there's an x in the g function, you put the f of x function in its place.
I don't get that.
Okay, well wait till you see an example. Just see an example. Alright, so let's say on this one, if I'm giving you that f of x is 3x plus 1, and g of x is x minus 4. Okay? So find both of them. This is the way it'll look. It'll tell you to find f composed of g of x. Alright, everybody ready? I want you to, everybody ready and listen. So this means we put our g of x function into my f function. You're going backwards. So that means I need to find f of, what is g of x? I need to find f of x minus 4. Just like that third example I gave you at the very beginning, and you said, oh yeah, I got that, I know how to do that. So don't even look at this anymore, that's gone. All that means is you put your g of x function inside of the f function. That means you find f, and you put the g of x function inside it, which was x minus 4. So now right here where there's an x, you just put x minus 4 in its spot, and you clean it up. So that means I will have 3 times x minus 4 plus 1. Or 3x minus 12 plus 1, which is 3x minus 11. And there's your answer. See, it looks a lot worse than it really is, right? Alright, let's go the other way. Let's find g composed of f of x. So now I want to find g composed of f of x. So we're going to work our way backwards. Everybody caught up with me? So we find f, we put our f of x inside of the g. Well, what is f of x equal to? 3x plus 1. So I need to put that in place of this x in the g of x function. So that'll be 3x plus 1 minus 4. 3x plus 1 minus 4, which is 3x minus 3.
Okay, quick question.
Okay.
Just to help me. Okay, I'm looking at the first one, like find. So whatever is the first letter is the letter that go on the outside of, let me bring it over. Like
The
F
first
O.
letter stays on the outside, yes.
Okay. And then the G is just whatever that is. I mean,
Yes, whatever's in this part, you think it's closer to the, it looks more like your g of x, what we have here. So that's what goes in there. That's where you evaluate it.
okay, and then that F of X, then I would choose that F of X because it looks like that.
Right.
Cool.
Very good. See, I told you it wasn't bad. Alright, let's look at another one then. This time, let's say if I give you that f of x is equal to x squared plus 1, and g of x is equal to x plus 2. Let's do this. Let's say g of x is equal to the square root of x plus 2. Let's up our game some. Okay? Alright, so on the first one we're going to find f composed of g of x. my g of x function inside of my f function. So I'm going to find f of g of x, which is the square root of x plus 2. Right? So it means right here where there's an x and f of x, I need to put the square root of x plus 2. So that's the square root of x plus 2 squared plus 1, right? Well, what happens when you square a square root? What do you get? You get what's underneath. So this would just be x plus 2 plus 1, which is x plus 3. Okay, there.
Why did you score, the second step?
Right here?
Yeah.
Because my x and my f of x function has a squared on it. So when you put it, whatever's in here, you put in place of this x, you've got to do the operation. You've got to square it because it's being squared. Right? If it was being cubed, you'd cube it. Or if it had a 2, like on the other one we did, if it had a 2 in front of it, or that one that we did, we just erased, it had 3 times x. So you had to distribute the 3, right?
Okay.
So whatever's happening to this x in that function, that's what you have to do to it when you substitute it in.
Okay.
You see what I meant? The one I just erased had a 3 times the g of x part. It had 3 times x minus 4 on it because it had a 3 in front of that x in that f of x function. This f of x function is being squared. So when you put the g in, you got to square it. Everybody okay there? Now let's go the other way. Let's find g composed of f of x. So we're going to put our f of x function into our g function. So we're going to find g evaluated at x squared plus 1. So that means right here in my g function, everything stays the same, except where that x is, I've got to put x squared plus 1. So that means I'm going to have the square root of x squared plus 1 plus that 2. This is my x, so that's what I put in. So that's the square root of x squared plus 3.
Can you go over it?
Okay. I'm putting x squared plus 1 in place of this x.
Okay.
So there's I've got my square root bar, which is on it. Here's where that x is. So that's the x squared plus 1. And then I've got the plus 2. So then I've got my x squared, 1 plus 2 is 3.
Okay.
Okay. The part that most people like better with the composites is what we're getting ready to do, when you actually plug a number in. So let's look at plugging in a number. So let's say if I'm given, here, f of x is equal to 2x minus 3, and g of x is negative x plus 5. This time we want to find f composed of g of 2. Okay, what's in the parentheses? A number.
Oh,
That means you're going to get a number for your answer, just like we did on those operations. Here there was x's in there. Your answer still had an x in it. Here there's a number in the parentheses. Your answer will have a number in it. This means I've got to find g of 2 and put that into f. That means I want to find f of g of 2. So let's find g of 2. What is g of 2? That would be what? Negative 2 plus 5, which is 3. So that just means I need to find f of 3. This is the whole walking backwards. Okay.
Back up there.
Alright, watch. Don't write for a second.
I can't.
Alright, stop and watch, and then you can write it all down. Okay? We're going to erase and start over. Okay. So this means I need to find g of 2, and then we're going to put the g of 2 into the f, just like we put the g of x in the f. This means I need to find f evaluating g of 2. But find g of 2. G of 2 is a number. Figure out, what's g of 2 equal to? Put a 2 in place of that x. That's negative 2 plus 5, which is 3, right?
Okay.
So that means really all I need to find is f of 3. It's walking backwards. Plug the 2 into the g. You'll plug the 2 into the g, get the answer, and plug the answer into the f.
Oh, so you just put the 3 into the 2 times x minus 3.
Right. So you put the 2 into the g, get an answer, and you put the answer into your f function. So then I'm going to have here, that'll be 2 times 3 minus 3. Or 6 minus 3, which is 3. So my answer is 3 there. Alright, let's keep going with these
She
functions.
makes me all up. She wrote that 3. I'm like, what?
Alright. Let's do another one here. Let's say this time if I want to find g composed of f of negative 1. So that means I put the negative 1 into the f function, get the answer, and put that answer into the g function. So first of all, let's find what's f of negative 1. Okay, so that's going to be 2 times negative 1 minus 3. Or negative 2 minus 3 is negative 5. So now I need to put the negative 5 into my g function. So that's g of negative 5. Whatever's in the parentheses, plug it into the f function first, get the answer, and plug the answer into the g function. So this will be a negative 5 plus 5. Well, 2 negatives make a positive, and 5 plus 5 is 10. Getting a little bit better? Alright. Let's see if you can, let's do a whole nother one. Let's say this time, let's say the f of x is x squared plus 2, and g of x is x minus 3. See if you can find f composed of g of 4. And then I want you to find g composed of f of negative 2. See if you can do those two. Y'all got these two problems done? Alright, let's see what we're gonna do here. So this means I need to find G of 4, get that answer, and then plug it in the F, right? So let's find G of 4. Okay, well G of 4 would be 4 minus 3, which is 1. Do you agree? So that means I just need to find F of 1. So that would be 1 squared plus 2, which is 1 plus 2 or 3. Everybody get 3? Follow me there. Now let's find G composed of F of negative 2. So that means I'm going to find F of negative 2, get that answer, and plug it in the G function. So let's find F of negative 2. Well, that's going to be negative 2 squared plus 2, which is 4 plus 2 or 6, right? So I need to find G of 6. So that'll be 6 minus 3, which is 3. All right, follow me on composite function. Okay, if you're struggling with these, just get lots of practice. You'll get how it clicks after the more you do. But it's always, like I say, it's always like walking backwards. Whatever's in here, put it into the first function. In this case, get the answer, and then plug that answer into the first function. All right? Well, now we're going to talk about linear functions. Okay? A linear function is a line. That was that basic function, y equal x, that identity function. It's the graph of a line. Well, these can be written in two separate ways. It can be written where you've got y on one side and the x on the other, which is called your y equal mx plus b, which is slope-intercept form. We're going to probably like this form better because this is where you do all that rise over run stuff that you find easy. This one, if x's and y's are on the same side, equal to a constant number, that's called standard form. Okay, what we're going to talk about today is how we're going to graph lines. Okay. First of all, we're going to talk about two special lines before we start digging into graphing. Okay, or how to graph two lines. First of all, if you have the line x equal any type of number, this means this is a graph where all your x's have to be the same. Anytime you have x equal a number, the graph will always be a vertical line. Okay, so if I had to say the graph x equal 2, that means you're going to graph a line where all your x's are 2. It's a vertical line. Do you agree every x on that line is 2? 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. 2, negative 1, 2, negative 2. Every x is a 2. Would you say this line's a function? No, the vertical line is not a function. Remember, it would fail the vertical line test. You'd put a vertical line right on top of it and it would hit it at every point. So vertical lines is not a function. And let's talk about the domain and range. Well, what's the only x value on this line?
2.
2. So your domain would just be 2. Your range, well, it goes all the way down and it goes all the way up, right? So your range is all real numbers. All right. We're going to come back in a few minutes and we're going to talk about the slope of this line. Next, your other special line is called the horizontal line. If you have y equal to some number, this graph is a horizontal line. All your y values must be that number. Like if you had y equal to. That's a horizontal line through where y is 2. Once again, every y value is the same thing. 0, 2, 1, 2, 3, 2, 4, 2, 5, 2, negative 1, 2. Would this one be a function?
Yes.
Yes, that passes the vertical line test. So y equal a number, a horizontal line, is a function. And now let's do the domain and range. Well, domain, this arrow's going all the way to the left, and it goes all the way to the right. So that means my domain is
All real numbers.
all real numbers. My range, well, what's the only y values here?
2.
P2. Now, for all of your lines, for every line except for these two, your domain and range are all real numbers. These are the only two where the domain and range are not all real numbers. Okay? We're going to learn that there are 3 ways to graph a line. The first way is if you want to do a T-chart, which we're probably not going to do many of those. The next way is by your X and Y intercept. Do we do an example of X and Y intercept? Maybe that first day where we let Y equal 0. So your X intercept, remember this is a point where you got some X value, Y 0. Find by letting Y equal 0. And it's the point where your line crosses the X-axis. Then you have your Y-intercept. Your Y-intercept is where your graph crosses the Y-axis. And this will always be when X is 0. And you'll have some value for Y. You find by letting X equal 0. And then our third way, which we're probably going to do the most, is when you have that Y equal mx plus b forward. And in this case, m is equal to the slope. And this is where you remember your rise over run. And b is equal to the y-intercept, where it crosses the y-axis. So you got the point 0b. So the only line that's not a function is your vertical line. All the rest of your lines will be a function. Okay, so let's talk a little bit about, before we dig into graphing, let's talk a little about what this slope actually means. We're running out of time. So we're going to talk about the slope of a line. The slope of a line measures the steepness of a line. The slope of the line will tell you how steep it is. You can have your slope, your formula, you're told that you're given 2 points, x1, y1, and x2, y2. Your slope is the difference of the y's over the difference of the x's. Okay? That's where the rise over run takes place, because you agree your y's, that's your vertical axis. That's up and down. Your x's are your horizontal axis. That's what we call it running. It's left to right. So slope is referred to as rise over run. And like I said, in our formula over there, slope will always be the number in front of x when you're having the slope-intercept form. But before we start digging real deep into all this with the slope, let me tell you this, you can have 4 different types of slope. You can have 4 kinds of slopes. The first kind you can have is a positive slope. And if you have a positive slope, this means that you have an uphill line. Your line will look like that, like it's going uphill. It's an increasing line if your slope is positive. You could have a negative slope. If you have a negative slope, your line will look like it's going downhill. When you read it from left to right. Third, we could have a slope that's equal to 0. A 0 slope means that you're not going uphill or downhill. You're just staying flat. So what kind of line do you think is going to have a slope of 0? A horizontal line. So anytime you have a slope of 0, this is going to be a horizontal line. Okay? a slope on a vertical line. So if your slope is undefined, this is the vertical line. So these are the 4 kinds of slopes that you'll encounter. So over here, where you wrote this down, vertical line, x equal a number, it's a vertical line. Come over here and put slope is undefined. Over here, y equal a number is a horizontal line. Go ahead and put on here, slope is 0. Those are 3 things you're going to have to memorize. They're going to come up a whole lot on this next test that people tend to mess them up. So, vertical line, slope is undefined. You can't measure it. Horizontal line, slope is 0. There's no steepness. You're not going uphill or downhill. Alright, so now let's do some graphing. So we know what slope means. Alright, so let's say if you're told to graph, number 1, let's do another quick example of x and y intercept. Let's say if I have 3x minus 2y is equal to 12. Well, if you're told to graph this line, and you want to do it by x and y intercepts, you need to find your x-intercept. Well, you find the x-intercept by letting y be a 0. Y equals 0. So that's when I have 3x minus 2 times 0 is equal to 12. Well, that's when 3x is equal to 12. Divide both sides by 3. So it's when x is 4. And you can tell by looking to another little shortcut. If it's in standard form, if y is 0, that term's gone. So when is 3x equal to 12? When x is
4.
4. So you don't really have to do all this work. You can tell by looking. Your y-intercept is when x is 0. Well, if x is 0, this term would be gone. Well, when is negative 2y equal to 12?
6.
That was positive 6 or negative 6?
Negative.
At negative 6. What's that? You can plug it in. Let x be 0. So that's when negative 2y equals 12. Divide both sides by negative 2. So it's when y is negative 6. And then we can graph them. We can plot these 2 points and connect them. We've got an x-intercept at 4. 1, 2, 3, 4. A y-intercept at negative 6. 1, 2, 3, 4, 5, 6. And then you can connect them. What would you say about the slope of this line? Do you think the slope is positive, negative?
Negative.
Positive.
Trace it. Bottom.
Oh.
So if it's increasing, it's positive. Right? It's going uphill. You read it from left to right. So that's how you graph that. Now let's look at one and when it's in slope-intercept form. Let's say for number 2, if I want to graph the line, y equals 2x minus 3. Okay, well, do you agree that this is in slope-intercept form, y equal mx plus b? What's my slope here?
2.
2. What's understood to be a denominator if it's not written? 1. And then what's my y-intercept? Your y-intercept is negative 3, so I've got a point at 0, negative 3. This is in the form y equal mx plus b. M's always a slope, b's always your y-intercept. Alright, well if my slope is 2, we just said slope was rise over run. Well, if your slope is a positive 2, what does rise mean that you're going to do? Go up. So that means we're going to go up 2, and run is your denominator. You're always going to run to the right. no matter what, always run to the right. So that means we're going to go up 2
Oh.
and to the right 1. So let's graph it. So first thing when you're told to graph using slope-intercept form is you plot the point you're given first. So we're going to plot this -3. As the slope measures the steepness, that change in the y's over the change in x's, we're going to do this rise over run, and you can get as many points as you would like. That means that from this particular point, if I go up 2 and to the right 1, I get another point on my line. If I go up 2 more and to the right 1 more, you get another point on your line. And then you can graph them.
You just want us to have enough points to make a line.
Yes. Okay, so let's look at another one. This is most people's favorite way of graphing. Y equal, let's say if I have -2/3 x plus 5. Well, what's my slope here?
-2/3.
-2/3, and my y-intercept would be 5, so it's 0.05. So to graph it using the slope-intercept form, plot the point first, 0.05, 1, 2, 3, 4, 5. Now this slope is -2/3. So since it's negative, instead of rising by going up, what do you think I'm going to do?
Go down.
You're going to go down 2. So this time we'll go down 2, but we're still going to run to the right 3. You will always run to the right. When your slope is negative, you just need to go in the negative direction 1 time. And we're always going to do it by going down. So from this particular point, to graph another one, I go down 2, 1, 2, to the right 3, 1, 2, 3, and make another point. Everybody okay there?
Mm-hmm.
Notice here, this slope was a +2, so this line is going uphill. Notice on this one, the slope is negative, so you see your line is going downhill. Also, which my lines aren't great, but this 2, this is a steeper line. It's getting closer to being vertical because 2 is a whole number. 2/3 is it's not as steep as the +2. If the number's a fraction, your line won't be as steep as if it is a whole number. All right, are we okay there? Next, let's look at another one. Let's see if we can use the slope formula. Okay, so if you're told now to find the slope given 2 points. So this means you're going to use your slope formula. The difference of the y's over the difference of the x's. Let's say if I had the point 2, 4 and the point -4, 1, if we can find the slope. Okay, well that means I need to subtract the y's. This is your x1, y1, x2, y2. So that'll be 1 minus 4 over -4 minus 2. So that gives me what? -3 over -6.
Mm-hmm.
Which reduces to a +1/2.
Mm-hmm.
So if you plotted those two points connecting, you would see you have a slope going uphill. Number 2, let's say if I have the 2 points, -4, 2 and the point 7, 2. So that's going to be what? 2 minus 2 over 7 minus a -4. Well, 2 minus 2 is 0 over, this would be 7 plus 4, which is 11. But what's 0 divided by 11? 0. So it has a slope of 0. What do you notice about these 2 points? Their y's are the some of your slope is negative. You'll see some of your x's are the same. It'll be undefined. And in my last minute, let me give you one up there so you can do one other thing. This kind of goes back here to the graphic. Let's say if you're told to graph the line with a slope of 1/2 passing through the point -1, 1. Would you agree that from any point on the line, the slope's the same? From any point on the line, you can do your slope, like over here where we went up 2/1. That's from any point on your line. Your slope is the same regardless of what point you start from. You don't always have to start from the y-intercept. So if we wanted to graph this one, you do just like we did on the other ones. You plot the point you're given first. So you plot that point, -1, 1. And now you do your slope. Your slope is 1/2. So what's that mean you're going to do here?
Up 1,
Up 1 to the right 2. So from this point, that means I will go up 1 to the right 2. And you have your line for that one. Now a lot of this stuff with lines should have been a review to you. Let me give you the homework in this section as well. I wrote the section 2A. So on page 225, you need to do 7 through 23 odd, 25, 27, 35 through 41 odd. 35 through 21 odd. And then 45 through 49 on, and then 53